Morning. It's noon. It's okay. Can you hear me? Okay. I think I have 18 minutes, where maybe if I overspeed, maybe by few minutes, pardon with me, or you can give me the alarm. I have been asked to deliver a talk on semiconductor and quantum. Now, these two subjects, if I have to talk at any level, I think it is not possible to cover even in a day actually. People study for 6 semesters and still they are not there. So my time will start after when I start my presentation. These are the, this is a building block actually. So once you make the plinth proper, then you can make 1 story, 10 story, 100 story building, and I'm trying to do that actually. So I think in this world, whatever we see, whatever we call at all development, it is all derived from the nature. I will give you 2-3 classic examples. One is that flamingo comes all the way and they go back. They had a navigation system by birth. Whales come from Australia to Porbandar and go back with the kids. Most important thing you must think about it, that when you look at a flower or a pot or this TV, how are you seeing this thing? So you have a camera over here, there is a light which falls on the object, it goes here. From here it is transmitted to the neurons in your brain. Up to that I think people are able to understand and explain. But how it is reconstructed as a flower within the brain, it has not been resolved yet. It is an unsolved problem. We know that electrical signals are going and it is firing the neurons. Do you know how many neurons are there in our brain? 200 billion. And then same thing happens over here. Sound comes. This is a collector of sound. This is not really doing anything. Like eyes do not do anything except capturing. All the processing takes place in CPU. So there is a semiconductor well designed within it. When the Shinkansen train was started in Japan for the first time, it was running at a very high speed. And it was making a lot of noise. They tried everything, but they were not able to suppress these things. So one of the guy, when he was on one of the large lake, he saw one bird coming at a very high speed and diving over there. And then he realized that there was absolutely silent at that speed. And he got the idea that how this bird is navigating through this. So if you look at this Shinkansen engine, its shape is like this. So what I am trying to tell you is that everything what we see today is derived from the nature. And when you go to the quantum, I will take you to the quantum also to a certain extent to make you understand. It is all unfolding what is happening in the universe. The classic example is that if I see that she is standing over there and we think that she is a real, but it is not real. She is not standing. Everything is spinning within her. Why so? If you can, do you know atom? Okay, if you do not know, you take a water drop or you take a metal, divide. When it is indivisible, what is left is you can consider as an atom. It has a neutron and proton and electrons flows around that actually. Now, if you really expand her and look at it, you will find that if all the electrons are spinning, how she can be stable? I think it is all, and people were not able to do these things. So people have been working for, I think, 1904 towards quantum and quantum physics and quantum mechanics. In 2024, there is a century has gone, and now people are able to certain extent realize. And there are 2-3 terms on quantum. One is superposition, second is entanglement, and third is dual wave theory. If you take home these 3 words and if you work on that, I am not saying that what I am going to talk is going to transform is a very big word, your life, but it will have definitely impact in shaping your life going forward. Those who do not invest time in 2 things, semiconductor and quantum, those who are going to be engineers or non-engineers, I will not call them illiterate, but they will regret for the lifetime. You cannot survive without applying semiconductor or quantum in your life. Quantum is going to hit in 5, 10, 15 years time. Today it is not commercially viable, but it is going to be viable. And for that, you must understand what is semiconductor and what is quantum. There is no need to do R&D or research work on all those things. Try to learn application on that actually. That is my message. Because Apple spends $25 billion a year on research. Likewise Google. TCS spends 2,000 crore. I don't think we can compete. We don't have that mindset to spend on R&D. So what we can do is to apply what is developed in the world actually. Please. Okay, semiconductor is ubiquitous. What does it mean? You know consciousness, you know God. We say God is everywhere. Likewise, semiconductor is everywhere. Just to give you an example, I was counting last night at my home that how many semiconductor chips I am using in a day without touching car. I found out 650 to 700 chips I am using, and every one of you using it. Do you know how many chips are there in modern non-EV car? 15 to 1700 chips. In Tesla, 3500 chips. All the things you see in your universe, all the appliances were dumb 10 years before. Today everything we have injected intelligence in every appliances. You go near the fridge, it will open. You put a vegetables on microwave, it will have a recipe. It will cook for you. When the child is born, if there is a swing, if the child cries, it will start swinging. And there is a satellite. So from birth to going to the moon, everywhere there is a semiconductor. The silent powerhouse of 2024-25. It is a fundamental industries. All industry you see is revolving around semiconductor. Whether it is a robot, and she was telling that there are 21 million codes and 30 million codes and 1 billion codes. Where are they residing? Where are the data residing? They are residing in semiconductor. So I am not going to teach you physics over here. That is not the purpose of this talk. This idea is to just give you the glimpse of what this subject is all about and what this technology is all about it. Every AI breakthrough, every electric vehicle, every 5G call, every cloud services, they are powered by silicon. What is silicon? I think if time permits, we will discuss, or after this we can talk on that. Without semiconductor, AI is theory. EV is only drawing and cloud is a vapor. All this has no meaning if there is no semiconductor. Where AI operates on, where this is operates on, there are chips inside, there are chips inside, there are chips on this. Just whatever you can see, it is ubiquitous. Everywhere. Only thing you don't have eyes to see. We are not visible. Next decade will be defined by AI and quantum computing. Quantum computing is a subject, I tell you, you get into it, it has a more impact than the drugs. You will never be able to get out of that actually. It is so entanglement. And you love the subject once you enter that subject. I am going to talk on quantum to a certain extent. Let me finish semiconductor because that is the base. Once I am done that, I think it will be easier for you guys to grasp what is quantum computing. So look at this. See why we are talking about silicon. So there is a conductor. So let us go to semiconductor. So there is a conductor and there is an insulator. I think that much you understand. That copper is a conductor and glass is a insulator. the things which is intermittent is called semiconductor. That means you can make it a conductor or you can turn it off as a insulator. That is the power of semiconductor, and that's a switch. So silicon, if you look at it, that is the main material. If it is dot with a boron or if it is dot with a phosphorus, either it has a one hole or it has one extra electron. So one becomes P and another becomes N, and that makes the PN junctions, and it makes a transistor. So transistor is a switch, on-off switch, and on this principle entire computation and the information storing and transforming is happening. So it is a 0 and 1 binary state. Binary language is 0 and 1. So the transistor is on, you can call it a 0. When it is off, you can call it a 1. And then 0, 1, 1, 0, 0, 0, 1, 1. If you have two binary codes, you can have 4 variables. If you have 3, 8. And likewise it goes on actually. So bits and bytes, you know about it. So this is the fundamental of any electronics or computing basis actually. So that is why silicon and germanium, they have 4 valence electrons. You should know this, what is this electrons about it, because if you don't know this, if you don't see this, you will not be able to apprehend quantum. Quantum is going to talk only on this, and that's why I am just showing this picture and not to teach you physics. So I talked about transistors. These myself, solid state transistors, and Gujarat University, we were born in the same year. When I did my graduation, I have studied only valves, vacuum tube valves. I don't think anyone of you has seen, even your parents has not seen. There used to be a radio where you can tune the capacitors, and then there was a needle which was moving, and then we were having the AM radios, not even FM radio at that point of a time, aptly modulated. And the word transistor came when the solid state device came into picture. So first semiconductor transistor, I think there is a, you can see this, you can read through this, I don't want to go into this, but it has a journey. And today it's a different world actually, and I think we are familiar with Intel Core and the Platinum processor. Today i7 is normally used for general purpose, because otherwise you will not be able to load some of the programs. So i7 is the latest core, and then you see how many transistors are there, how it is marketed. So what has happened in last 40 years, since 1949 to 2025 is phenomenal. Today we are talking about few billion transistors. I was talking to you about car. The chip which is used in any automotive has nothing less than 6 billion transistors in one chip when it is a processor. We are talking about billion. Billion is 1000 million is billion, and 1 million is 10 lakhs. So you can calculate. This is the journey. Look at this, where we are heading. 10 billion transistor in 21. How many of you know NVIDIA? All of you. What do they make? AI chip. AI chip. How many transistors are there in AI chip? Any number? Please. 280 billion transistors are being used actually in one chip. Now in AI chip, so much of power is consumed that you need a cooling towers to make these chips cool. See, you think of yourself, when your mind is working very fast, no, you get headache. This becomes hot also. So our mobile phone is i15 or 16 has almost 15 billion transistors, and every second they have 1 trillion transactions within this. Now if that is the speed, if it is operating at, what happens to that particular thing? If we get headache, we get temperature, what will happen to that device? So that is where the technology comes into picture, and today all this mobile has nothing less than 10 billion transistors. So I don't want to go into the more details about these things, but what has happened that Golden Moore, he is the father of this concept. It is not like E equal to mc square, the formula, but he could observe that every 18 months, the number of transistors on a given slab of silicon is going to be double, and size is going to be half, and the cost is going to be 1/4. And it is going on. Today, we are making the chips. When this was happening, it was 300 nanometer, then 180 nanometer. Today, we are talking about 2 nanometer and 1.5 nanometer. We are coming up with the manufacturing plant in Dholera by Tata. They are investing $10 million. The chips which we are going to manufacture there are from 28 nanometer to 110 nanometer. We are not talking about 2 nanometer, 3 nanometer or 7 nanometer. The cost of putting up that foundry is within the range of 20 to 25 billion dollar rupees. If you want to do that, and we don't need. Right now we need a matured node where the technology is proven, yield is good. And all appliances, automotive, other things are well managed within 28 to 65 nanometer. So that is why we are going there, and we are starting with there actually. You might have read in the newspaper day before yesterday that CG Power has started their pilot plant for packaging those chips. So Tata is going to make the chips, and balance people are going to package those chips. I will take you there, what is the entire process. But they say that they are going to package in the full stream 14.5 million chips every day. How many? 14.5 daily in one plant. So here you can think of. And worldwide, in India, in Sanand itself, we have a 3 plant coming up. We have 1 plant coming up in Surat, Ncubesemicon. There are some plants coming up in UP and other parts, Karnataka. So think of, you just calculate per annum how many chips will be packaged only in India. And likewise, there are nothing less than 300 plants globally. That is the requirement of the semiconductor. These fabs are very expensive, as I said, 10 billion or 20 billion or 25 billion. And it is like a car. If you purchase a car and keep it at your home and don't operate, still there is a cost. Likewise, if the fab, if you don't operate, it costs you $1 billion per annum. So fab cannot remain empty. They cannot remain hungry. So what you have to do? You have to design the chips. Who will design the chips? People like you. India is designing 20% of the chip globally. In last 20 years, whatever chip has been come on this globe, there is an Indian in every chip. In one way or other, Indian engineer has been there. We have 1,20,000 engineers today in the country. There are almost 3.5 to 4 lakh engineers working in US, entire US, and 30% of that are Indian. There are very interesting slides going above what Indians are doing in this technology world. We will see little later, but this is what is happening. I was talking to ma'am just before this lecture started that people have a very poor referencing, and that's why they understand what do your kids going to do. He say IoT and IT and Python and this, that. In semiconductor world, the salary are, you cannot think of. 1 crore rupees salary is not a big thing per annum. The normal multiplier is 7. That means the number of years of experience into 7 is going to be your thumb rule salary. But depending upon individual caliber and experience, it can be anything. So think about it. Why I am talking about designing? Because before 1985, there were companies like Intel and Philips and all those things. They used to design. They had a fab. They used to manufacture. They had a packaging units, and they used to package and sell globally. So TSMC in Taiwan, they first put up one fab. Fab is a foundry where the chips are manufactured, and they are not designing. So what has happened? Company like Einfochips mushroom. So you want to design, she wants to design something from avionics, she comes to us. We design chips. Earlier there was no way to manufacture them. Now I go to TSMC or UMC and get it manufactured. Then I go to this Micron and other people to package it. And then she will make use of it and then make the aviation part of it actually. So it started. India was 10 years ahead of Taiwan. Today Taiwan TSMC, they rule 70 to 80% market of this 2 nanometer and 5 nanometer technology worldwide. They are daddas. We were 10 years ahead of them. We put up first plant somewhere in 1976 in Mohali, semiconductor lab actually. Then after some time it got fired. And then government changed, and then I think Narendra Modi ji, when he was CM, he tried to bring one in Prantij. But then the central government was different. So Chandrababu Naidu snatched that project to Andhra Pradesh. And he was thrown out because he was considered as a capitalist. And likewise thing happened. And we remained where we were. But actually, I think this new government is definitely very progressive. Irrespective of the Modi ji or no Modi ji, now things have started rolling. And we have one first fab in the country in Gujarat. And we have the highest number of packaging plant in India. So India is becoming a semiconductor hub, an epic center. And Gujarat is going to be the epic center there. Look at this. Okay. No. This is different, that is different. Okay. This is showing the market cap. You must see anything which you develop, if it doesn't have a commercial value, it has very limited use. You have to democratize whatever you make, whatever you develop. There are a lot of startups. I go and ask them that who is going to sell your product? Who is going to sell your solution? That is the biggest challenge in any startup, to get the sales. You can always hire the engineers to develop it, but selling is a big challenge actually. Let us look at the GPT, Chat GPT. How many of you know? Do you know full form of GPT? GPT full form. Anyone? Search, Google. Generative pre-trained transformers. If you have not heard. Now they are known all the places. Now that is where the AI is working. What is the market cap of OpenAI? Less than trillion. Nvidia is making those chips. What is its market cap? 3.4 trillion. What is the GDP of India? Same. They can buy out India. That is the power of semiconductor. What I am trying to tell you is that actually. What makes sense? To develop GPT or to develop semiconductor chip? To me, it makes sense to make GPT, Nvidia. Madam, time hai na? I think so. We can stop this and then I can continue for 10 minutes without TEDx. So what drives, where these chips are used, it will give you some idea where the chips are being used actually, because it has to have the application. Once again, I don't want to repeat, but there is nothing, no product which can be thought of without chips or semiconductor. This is one slide, this is little old, but actually what I was trying to tell you is this, that look at these top giants. This put together can buy almost the whole world with their market cap. That is the power of technology. So whether you want to put hands or not, that's your choice. Okay, who drives this GDP? Look at this picture. All of them are Indian. The world GDP is close to $110 trillion. And these people all put together is driving $85 trillion. So we are brain. You may not be aware, but there is a guy called Mistry from Palanpur. Pranav Mistry. Anybody has heard the name? He passed out from Nirma. He is in the think tank of Samsung. You might have heard A.M. Naik, chairman of L&T. He studied in medium Gujarati till first year of science. He passed out from BVM, no master degree, nothing. He took L&T from 4 billion to 30 billion organization. So one of you should be here in coming 20 years time. I think that's what you should look at it actually. This is the whole process from sand to silicon. See, it is important to understand that to make one chip, it is made of silicon, SiO2, silica. It has to travel 50,000 kilometers to come from sand to silicon in your hand, where she can use it. It crosses almost 50 plus countries gate. Today in the world, there is not a single country they can say that we can independently make chip from sand to silicon. And you might have heard that Mr. President Trump, he tried to impose restriction on China, and then China said that we will not supply you this material, rare earth material, and he nailed down. We will do the same thing if he acts too smart. He has to nail down, because all the chips are designed in India. 90% of R&D centers, of global capacity centers, global centers, conglomerate are in India. 90% of R&D is happening here. So if we impose 50% or 100% tariff on that, all this Google will have trouble. We are not doing that. This is designing. I don't want to go there. Let me tell you on quantum little bit of.